In this lesson, we will be learning how to multiply polynomials. And in order to do that, we need to review on how to add polynomials and how to multiply monomials. We've done both. So the first one, how do you add? You have to have like terms, meaning the letters have to be the same and their exponents. So you keep the letter in the exponent and you add the coefficient. We've done that since lesson 1. Now when you multiply a monomial times a monomial, you can just multiply the numbers, the coefficients. Then we're going to use our rules of exponents. Since I have the same base of x, I would keep that base and add those exponents. Let's just do another one. What if I have 5x cubed times 7x to the 5th? 5 times 7 is 35. Keep the base, add the exponents. Another thing we've done since day 1 is we've used our distributive property, which is also a type of multiplication. And now we have a monomial times a binomial. So we would distribute and say that is 20x. And here we have minus 45. We've done all three of these things many times. So, how do we multiply polynomials? We're going to use the distributive property. We're going to multiply each term by the first polynomial with each term in the second polynomial. Then we simplify by collecting like terms. So we have to put together a lot of things we've learned in the past, collecting like terms, rules of exponents, all those things. The good news, it's pretty easy. Okay, so I have this monomial and I'm going to distribute it inside this parenthesis to all four things. So I have a polynomial here and a monomial here. So I'm going to multiply those first two things by multiplying the coefficient. So I have negative 12. Keep the base of x and add their exponents. Keep the base of y and add their exponents. Now the next one, I have a negative times a negative, so it's positive. The 3 times the 3 is the 9. Keep the x, remember that's an exponent of 1. Add it to the other exponent, and then I just keep the y. It's being multiplied. Now here, a negative times a positive is a negative, so I have 21. Keep the x squared that I had in the original monomial, and then the y's, I'm going to add their exponents. Then the last thing is multiplying times positive 2, so that would be negative 6 x squared y. And I guess I should have looked to see are there any like terms before I'm thinking I'm done, and I don't see any like terms. All the letters are the same, but all of the exponents are different. So that would be my final answer. So that's a monomial times a binomial. Oh, no, a monomial times a polynomial. Now what do I have here? I have a binomial times a trinomial. So I'm going to go back and say I multiply each term in the first polynomial with each term in the second polynomial. So that means I have to distribute this 2x to all of those, and then I have to distribute the 6 to all of those. So let's take it a step at a time. Alright, so 2x times 3x cubed is 6x to the 4th. That's here to here. Then positive 2 times negative 8 is negative 16x squared. And then positive 2x times positive 6 is positive 12x. Not done. Now I'm going to come back and do the 6 times that, which is, I'm going to say, plus 18x cubed. 6 times negative 8x is negative 48x. I'm just going to the next line because I ran out of room. And then 6 times 6 is positive 36. Am I done? Are there any like terms whatsoever? I'm looking, and that's the only like terms I see. So let's put those together. I'm going to write my answer in standard form because I can. So I have 6x to the 4th plus 18x cubed minus 16x squared, and now I'm going to put my x's together, so that's minus 36x plus 36. Descending order, I've collected all the like terms. I think I've not made any mistakes. Now the next thing is a binomial times a binomial, and many of you have learned this with the mnemonic, the FOIL method. FOIL stands for first, outside, inside, last. Sometimes you've learned it as first, outer, inner, last. It doesn't really matter. It's still the distributive property. But this is for a binomial times a binomial. And what happens is we have x times x, which is your first, x times negative 9, which is the outside of the parentheses, 7 times x, which is the inside, and 7 times negative 9, which is the last in the parentheses. But you can see it's exactly what I did on number 2. It's just the distributive property. Every term in the first parenthesis multiplied by every term in the second parenthesis. So x times x is x squared, x times negative 9, 7 times x, and it's positive, and 7 times negative 9. Are there any like terms? Yes, there are. We call those the middle terms. They're in the middle. They're usually alike. Sometimes they are not the same. But in this case, we can add them together, and our answer is in standard form. And just to review some vocabulary, we get a trinomial. All right, let's practice number 4. Has a few more letters. So 6x times 5x, that would be f, the first in the parenthesis. That's 30x squared, because we're multiplying x times x. Then the last in the parenthesis, that's going to be positive 12. xy, you usually put your letters in alphabetical order. Then we're going to have negative 25xy and negative 10y squared. Y times y is y squared. Again, those middle terms in this case happen to be the same. So we're adding like terms. That means the letters don't change. We add the coefficients. So in this case we would subtract and take the sign of the larger. And again we get a trinomial. We have some special products. Type 1 is two binomials that have the same first term and the same last terms, but they have opposite signs in the middle, are called conjugates. So look at number 5, look at number 6. You can see the parentheses are exactly the same, except one is positive in the middle, one is negative in the middle. Let's see what happens. Okay, we can just use our same way, x times x, x times negative 2, 2 times x, and 2 times negative 2. And then look at those middle terms. What happens when I add that together? They get 0. So all I'm left with is here, x squared minus 4. That's what happens when you multiply conjugates. Those middle terms will add to 0. So if you recognize that and you just want to write down the answer, that's okay. But if you forget, you can always use the distributive property. So I recognize the fact that those are conjugates, so I could multiply the first and the last and be done. But if you're not sure, you can still do the first, outside or outer, inside, last, and those middle terms will add to 0, and you get back to that. So if you can recognize that pattern, and it really is good if you can, that we can see if we multiply two conjugates, your answer is always going to just be a squared minus b squared. So let's see if we can use that shortcut on number 7, but we have to make sure, are those conjugates exactly the same except for the sign in the middle? And yes, it is. So we can do the first term and the last term. And you're done. Let's look at number 8. Are those conjugates? Yes, they are. Exactly the same except the sign in the middle. So we can multiply the first terms, that's 100x squared. Multiply the last terms, that's 9y squared. And you're done. You should like those. But don't be lulled into a false sense of security. Books, worksheets, tests all try to trick you, so be very careful. The next thing we're going to do is square a binomial, meaning you have something squared. Okay. These are not conjugates. When you square something, that means write it down twice exactly like it is. So this means x minus 7 times x minus 7. Not conjugates. All right, not conjugates. The middle terms are not going to cancel. So let's FOIL. That's x squared. That's minus 7x. That's minus 7x. And that's a plus 49. Now when we look at those middle terms, those do not add to 0. In fact, they add together and you get minus 14x. In fact, you get two of exactly the same thing. That's a nice pattern to know, but again, you can always do that FOIL method. Right, so we have 3x plus 4 times 3x plus 4. Right, so we multiply, and since we're squaring, we're going to get the same middle term again with the same sign because they're not conjugates. Okay, those middle terms are going to be the same, and we add them together. So could you do that in your head? If you can, that's great, but please be careful. All right, I'm just going to do it the slow and steady way. I'm going to write it out twice, and then I'm going to FOIL. And now I know that that's going to be the same. And notice that that last term, when you multiply the last in the parenthesis times the last in the parenthesis, is always going to be positive because you're multiplying the exact same number times itself. So we have minus 12x plus 9. Now why this is important to practice and see these patterns is because in the next chapter or the next topic we will conquer in this class is going backwards of this. We're going to start out with those problems and you're going to have to tell me, hey, it came from that. So recognizing patterns in math is a big deal. So we have 5x plus 6 times 5x plus 6. Again, multiplying. I know the middle terms are going to be the same, so I can put them together. Before we finish, I want you to look at all three of these answers. They all came from squaring a binomial. When you square a binomial, you're always going to get a trinomial. Always. In fact, they're a very special type of trinomial. They are called a perfect square trinomial. A perfect square trinomial. Perfect square trinomial. When we get to the factoring stage, we will see a perfect square trinomial comes from squaring a binomial.